Hello guys, and welcome to this video on acid-base equilibrium. In these videos I will show you which side of an acid-base equilibrium problem is favored. And a good note to know is that acids tend to have a positive formal charge while bases tend to have a negative formal charge or neutral. So acids, let me write this down. Acids equals positive, all right, FC for formal charge, or neutral, so neutral. Bases tend to have a negative formal charge or neutral. And if you look at this example right here, you would see that, oh, they're both neutral. There's no formal charge. Well, there actually is a formal charge. This lithium is a metal, and we know nitrogen is a nonmetal, so that is forming an ionic bond. So lithium is found in group 1, so has a positive formal charge, and nitrogen would then have a negative formal charge. And what is an ionic bond? An ionic bond is just an electrostatic attraction between two atoms in this case. So let's draw in our lone pair of electrons to finish off explaining that. And if you check the formal charge on this nitrogen, it indeed has a -1 formal charge. So negative formal charge means it is a base. So let me write that down, base. And if this is our base, then water will be our acid. And water is special because it can act as a base or an acid depending on what it's reacted with, and we call that amphoteric. So let me redraw these molecules over here by just copying and pasting them so we save time. Okay, so let me keep doing this. Okay, we identified our acid and our base. And what an acid does is an acid donates a proton, and a base will accept that proton. So we will use electron arrows to show what we're doing here. We'll be forming a bond and we'll be breaking a bond. So we started our lone pair to form a bond, and we can either take this proton or this proton. It doesn't matter. They have the same acidity. And I have problems that are hard like that, and I'm not for sure which part that will be, but just go through these videos and you'll end up finding an extremely hard problem, and I'll explain everything. So we formed a bond right here, and then we also have to show that we're breaking a bond. The reason being is we're only taking that proton. We are not even taking those electrons. Those electrons are being pushed back onto that oxygen atom. So let's show what we did over here. So we formed a bond with this nitrogen, this lone pair. So let me remove that, draw in our bond. So we made a bond there, and we originally had a negative formal charge, and we took a positive or a proton, so that will counteract that negative formal charge, and this molecule now has no formal charge. And you can check the formal charge on that nitrogen again, and you will indeed find out that there is 0 formal charge on it. So what do we do to the water molecule? Well, we took its proton and pushed electrons onto it. So let's show our lone pairs. So we removed this hydrogen, this proton I should say, put it onto this nitrogen right here, and formed a bond. And we took this lone pair, or this bond really, and made it into a lone pair by breaking that bond and placing them onto this oxygen. So here's our lone pairs of electrons, and now we should see that this is a hydroxide anion, and a hydroxide anion has a negative formal charge on the oxygen. And you could check out the formal charge formula, which would show 1, 2, 3, 4, 5, 6, and 7. 6 minus 7 is -1. So I'm going to write a plus right here. So we can't forget our lithium. So our lithium ion, our cation, is floating around, and this is just good to know. Since this lithium cation is positively charged, it will be close to this negative formal charge. It will be surrounding this hydroxide. So I'm just gonna leave it right here still, but this is what our equation should look like. So which side is favored? Well, we need to figure out what is our conjugate acid. I'll write Ca for conjugate acid and Cb for conjugate base. So our conjugate acid is the molecule that gained a proton. So this molecule right here gained a proton. So that is our conjugate acid. And our conjugate base is the molecule that lost a proton. And this molecule right here lost that proton. So our hydroxide anion is our conjugate base. This lithium, if you want to know what it's called, I think we just call those spectator ions. So we don't really have to worry about those. We're just focusing on our acid base and conjugate acid, conjugate base. But how do we determine which side's favored? Well, we compare our conjugate base to our base. Now, our nitrogen has a negative formal charge, and our oxygen has a negative formal charge. So, which side's favored? So, this side is favored. Why? Because oxygen is more electronegative. It likes to have electrons around it. While nitrogen is electronegative, but not as electronegative as oxygen, so it's more stable, if you want to say, with the negative formal charge on the oxygen. So you might see a multiple choice answer. If by chance your test or quiz is multiple choice, you can see this. Let me do this. This arrow as smaller than this arrow because this side of the reaction is favored. So why again is this side favored? Because of elemental reasons, and specifically electronegativity. So that is your answer and reasoning for this problem. I hope this video helped. If it did, give it a thumbs up, subscribe, and comment if you have any questions down below. I'll be sure to answer them. And yep, so that's it.